Okay, next one. Describe what happens with seafloor spreading. This is another thing that we kind of got stuck on. And I get it. It's freaky. It's freaky stuff, okay? So let me break it down once again. What is that seafloor spreading? Well, we've got 4 steps that are going to happen. Let's go through them. With seafloor spreading, you have the oceanic crust. So again, it's in the sea floor, it's in the sea, so we know it's going to be in the ocean. That's why it's oceanic crust. Spreads apart. I mean, duh, seafloor spreading. The seafloor spreads. So if you see right here, we have in the brown that oceanic crust. Notice how it's slowly spreading apart. Okay, so after it spreads apart, magma in that asthenosphere, that magma rises through the crack. So once it separates, that sounds kind of gross. Once it separates through that crack, that magma is just going to pop out, right? Because there's nothing stopping it from popping out. So once that magma rises through the crack, that magma is then going to cool to form new crust. So this is a major throwback. You can think about that igneous rock. Remember how we talked about magma or lava cooling and hardening to become a rock? That's exactly what is happening here. So that magma comes up, it cools off, forms a nice rock to form a new crust. So then that old crust is destroyed at subduction zones. Okay, hopefully I didn't lose you right there with that. So think about it. If we're constantly creating new crust, wouldn't the whole earth be covered with crust? Wouldn't we all just be like, there would be no ocean, right? Because we're constantly making new land. What the heck? So any old crust is going to actually be recycled or destroyed, put back into the inside of the earth at those subduction zones. So here we've got the ocean floor separating, spreading to make new crust. And then down here at what we call our subduction zones, remember we talked about those with volcanoes, at those subduction zones, that is when that old crust is going to sink back down into the earth and be destroyed. That last part isn't nearly as important as steps 1 through 3 because this is how that new crust is being made. So that oceanic crust separates, magma comes up, it cools and hardens to form new rock, and yeah, it's just constant. And remember where that brand new crust is formed, we call that mid-ocean ridge. So don't forget that mid-ocean ridge. It's like a mountain made in the middle of the ocean. Pretty cool. All right. I told you guys we got a lot to get through, but it's okay. We're going to make it. We also talked about those plate boundaries. So that is where those different tectonic plates, I wish I had a picture, those different tectonic plates come together like those puzzle pieces that they are. So the edge where they come together are those plate boundaries. Now we talked about 3 different types of plate boundaries, and they are named differently based on how they are interacting with each other, okay? This is where that horrible rap came into play. I know we loved it so much. So those 3 plate boundaries, they are going to have different things happening at them. So let's get into it. That first one, we have those convergent plate boundaries, and I want you to think convergent collide, okay? So that's where those 2 tectonic plates, when they're moving, they are going to collide with each other. So convergent, collide both start with C. You can recognize in a picture that it's convergent because the arrows are pointing toward each other to show that they're colliding, all right? So here, the lithosphere, now this part we didn't touch on too much, but that crust, that lithosphere, it's going to be usually destroyed because you're banging into each other, right? Now, what's formed at convergent boundaries? You can have an earthquake happen there. Of course, that land's going to shake a little bit when it bumps into each other. You can have a volcano form, and you can have mountains form. So a volcano is going to form if you have that oceanic crust bumping into either another oceanic crust or a continental crust, so dry land, or if you have 2 oceanic crusts coming together. But if you have 2 pieces of land coming together, that rock, when it bangs into each other, it's going to build up and form a mountain. The other type of plate boundary we have is divergent. And when you see divergent, I want you to think divide. So convergent, collide, divergent, divide, just like that rap told us. So when you see 2 arrows pointing away from each other, they are dividing, they're separating. okay? So here we're going to have more earthquakes because the earth is moving. You can also have volcanoes form at divergent boundaries, or that's where you get that oceanic ridge forming because of that seafloor spreading, because see how they're dividing? So that is a divergent boundary. Okay, lastly, we can have a transform boundary. And here, think slide. So transform boundary, we are sliding. Okay, so we know we're looking at a transform boundary when you have those arrows pointing past each other because they're sliding past each other, okay? And really, you're not going to have any landforms being made at a transform boundary. You're just going to have some earthquakes happening. That's it. Okay, moving on from plate boundaries and tectonic plates. Oof, over that stuff, right? Here's something a little bit easier, or at least I think it's a little bit easier. We are talking about constructive and destructive processes. So remember, a constructive process is anything that's going to build up Earth's surface. You can think of construction, or construct means to build. And destructive is the opposite. So this is destroying Earth's surface, okay? So for each of these processes, we need to label them as being either constructive, so building up, destructive, destroying, or both, because some things can be both. So first, we have that weathering and erosion. That's when actual weather is going to hit the Earth's surface and cause it to break down. So since it's breaking down, that is destructive. So same thing with erosion. Weathering and erosion, destructive. Next, we have landslides. Landslides are actually going to be both. Okay, they are both because a landslide is when that land on like a hillside is actually sliding. Pretty easy. So it's breaking off of one landform. So that's how it's destructive, because that rock is being broken off, but it's going to end up being placed on top of another piece of land. So it's going to build up somewhere else. So that's why it is both. Okay. Next, we have our seafloor spreading. We know this one. We know it's constructive because it separates, that magma comes up and cools to form that new crust. So you are building up the earth. That is constructive. Next, we have earthquakes. Earthquakes are destructive. You're not building up anything with an earthquake. You're just destroying everything. So that's why it's destructive. Then we have that deposition. And again, if I'm going too fast, I don't want to waste your time, but if I'm going too fast, just pause it and get it down. Deposition, that's when those pieces of dirt or sand or clay or whatever are being deposited or dropped off in a new location. So that's building up the earth. Okay. Now, next we have floods. Floods is going to be both. It can be constructive because they can help with deposition, so that water can carry in new pieces of land and drop them off on an original piece of land. So that's how that's constructive. And they can also become destructive because that a large amount of water can break off pieces of land when it's coming through. So that's how it can be both. Last but definitely not least, we have those volcanic eruptions, and those are also going to be both. They can be both because the lava can burn down pieces of land, and that's how it is destructive. Or if it is an underwater volcano, that lava can cool to form an island. Are you ever in the middle of working and you're just like, I need to change where I am, like the setting, I'm getting tired, like I need to switch things up? That's what just happened to me. Okay, so we've got only 3 more slides, so let's fly through these, okay? So this slide here, it says identify each example as mechanical or physical or chemical weathering. So we're talking about, the breaking down of that soil. We remember that mechanical weathering means that the rocks or the soil is just being broken down into smaller pieces. So what they're actually made of does not change, they're just made to be smaller. But with chemical weathering, the actual chemicals and everything that is making up that rock or that soil is totally changing. So it's not the same exact thing as it was before. Okay, so for each example, we're going to put it as either mechanical or chemical. So the very first one says burrowing animals break apart rocks as they dig. So remember that anytime an animal is burrowing, just means digging a tunnel in the ground and making the rock smaller. That is going to be mechanical. So we'll put that under mechanical. Number 2 said acid rain wears away the words on a tombstone. It sounds spooky. So anytime you see the word acid involved, you know we're going to be talking about a chemical change. So we're going to put that under chemical. So again, anytime you see acid, think chemical weathering because it's totally changing the makeup of that stone. Number 3 says a rock changes from brown to red. Now, this part we barely touched on when we talked about soil, but I want to make sure this is really solid in our brains. If you see a color change, that's probably going to be chemical weathering. Think about when we talked about that oxidation, how if enough oxidation happens to a car where it changes the color on like an older car, oxidation meaning it just reacts with the oxygen in the air, that is a color change. So that is always going to be your chemical weathering. Okay, number 4 says plant roots force their way into a crack in the sidewalk and cause it to split even wider. So again, when we're talking about plants breaking rock into smaller pieces, that's going to be your mechanical or physical because the rock itself isn't changing, it's just getting smaller. Number 5 says a rock slowly dissolves in water and breaks into different separate elements. Okay, this one is super tricky. The key word here, or key words, are breaking into different separate elements. So when it says elements, that's just talking about, again, the things that are making up the rocks. So if we are breaking down and separating those elements, what makes up that rock is no longer the same. So if you see anything about the elements of a rock changing, that is going to be your chemical weathering. Okay, number 6 says water wears away rocks into smaller pieces. There's that key word. At a shore due to waves crashing. So remember, anytime something is crashing into the rock and causing it to break down, that's going to be either your weathering or your erosion or your abrasion. Remember the word abrasion. So that is going to be mechanical because what's actually making up the rocks on the shore isn't changing, it's just getting smaller. Number 7, last one, says water freezing in cracks of rocks and expanding to break the rocks apart. Same thing as number 6. That one is going to be mechanical because, again, that's that ice wedging. And again, the rocks aren't changing. What makes up the rock isn't changing. It's just breaking down into smaller pieces. Okay, 2 more slides. We've got another one with soil, but this one is a little bit easier. So which of the 2 samples, we have sample A and sample B, which of the 2 samples has the greatest permeability or porosity? And explain why. So remember, porosity is talking about the pores that are in the soil. And the pores, remember, those are holes or little cracks in the soil that water and air can travel through, okay? So as you can see right here, there's some empty space, and over here we have some empty space as well. So, key thing here, remember the bigger the particles in the soil, and when I say particles, I'm talking about that clay, sand, silt, those are the particles. The bigger the particles, the bigger the pores, and the bigger the pores, the bigger the porosity. Okay, so obviously soil B here has much bigger pores. This looks like it's made up of probably gravel. Over here we've got some smaller, probably silt or sand. So we're going to say that soil B has the greatest permeability or porosity, and that is because the larger particles allow more space to hold water and allow water to flow through. So if you are planting something that needs a lot of water, you're probably going to want to put it in soil B because it's going to allow for a lot more water to pass through as opposed to soil A. Okay, final slide. The last thing we talked about in this unit is that gorgeous water cycle. So what I want you to do for this, look at that cycle. It's not really labeled, but we've labeled each part with a letter. So we're going to say what each letter in the hydrologic, I can't speak, hydrologic, which is just a fancy way of saying water. What do these letters represent in the water cycle? So let's start with letter J here. Let me move myself. Letter J here, we see some water or rain or snow or sleet or hail, whatever, falling from the clouds in the sky down to the earth. And we know that is going to be our precipitation. Precipitation. Again, precipitation is just a fancy way of saying rain, snow, sleet, hail, all that good stuff. If we look up at K, K here is where we have clouds forming. When we hear the C in clouds, I want you to think of condensation. Condensation. So here that water vapor in the air is going to condense, meaning get thicker and turn into a cloud. Cute. So here we have L, and if you look closely at L, it's a little hard to see in this picture, but it's labeled as a forest. So we have water coming from trees or plants going back up to the sky. So anytime you have water coming from a plant and turning into water vapor up into the air, that is going to be your transpiration. And we remember transpiration starts with a T, and so does trees. So think from trees to the sky, transpiration. Now, on the other hand, if it is coming from a body of water, or in this case the ocean, and going back up to the sky, turning into water vapor, that is going to be your evaporation. So if it's coming from a body of water, it's evaporation. If it's coming from plants, it's transpiration. Pretty easy. X, this one's a little tricky to see on this diagram, but X, if you actually look at the dotted line here, it's actually underground. So this is underneath dry land, and we have some water down here in the ground. So if it's in the ground, we call that our groundwater. And remember, this is where if you have a well, this is where that water is going to come from, a well that goes deep into the ground. It comes from that groundwater. Last but not least, if you look at Y here, again, this one's kind of hard to see on this picture, but we've got a lot of extra precipitation that is flowing over the surface of the earth, and it looks like it's going back into a big body of water, but it's not typically going to be there. So any extra water that came from precipitation that's running over, hint, hint, running over the surface of the earth, that is going to be your runoff. Sweet. Okay, and then it says, what do the arrows pointing down into the ground represent? So I'm talking about these arrows over here. They're not really labeled, but they're super important. So anytime you have extra water seeping or going down into the soil to eventually become groundwater, that is that process known as infiltration. So again, anytime you have extra water on the surface and it goes down into the soil, it actually going down through the soil is what we call infiltration. Whew. Y'all, we made it through every slide. I know that was a lot, but ooh, you are so prepared for this test. I can't even believe it. If you have any questions about any of this, please hit me up, because I'll tell you what, guys, this is a lot of content that we didn't have a lot of time to cover, and a lot of it's complicated. So thank you for bearing with me. You guys got this. I'm really not worried about you.